Here we have a telescoping series with the expression 3 over n squared minus 4. And I want to show that this infinite series converges to 25 over 16. And so the first thing we want to do is decompose this the expression 3 over n squared minus 4. And so and the equivalent expression would be 3 over x squared minus 4. And x squared minus 4 is x plus 2 times x minus 2. And using what's called partial fraction decomposition, we can rewrite this as some constant a over x plus 2 plus some constant b over x minus 2. To combine these two expressions, we can cross multiply, so constant a times x minus 2 plus constant b times x plus 2, dividing by the product of x plus 2 and x minus 2. From here, we have 3 is equal to a times x minus 2 plus b times x plus 2. This equation is true for all x. So to find a and b, what we want to do is pick something that would make this factor 0 and then make this factor 0. So let x be 2. Then in the place of x, we have 2 and 2. 2 minus 2 is 0. 2 plus 2 is 4. So we get b is equal to 3 over 4. And then similarly, we want to pick something that would make this expression here 0. So let x be negative 2. So in the place of x, we have negative 2. So this will be 0, and here we get negative 4. So here we get negative 4a. So a will be negative 3/4. And so we can rewrite the expression 3 over x plus 2 times x minus 2 as negative 3/4, because 8 is negative 3/4 over x plus 2, and then plus 3/4 over x minus 2, since b is 3/4. And to get rid of the fractions here, we can multiply, for this expression here, we can multiply the top and bottom by 4. So multiply everything on the top by 4, multiply everything on the bottom by 4. We get negative 3 over 4x plus 8. And then same thing here, we get 3 over 4x minus 8. So this is the original series. And now we can rewrite it as negative 3 over 4n plus 8 plus 3 over 4n minus 8, which is the same thing as 3 over 4n minus 8 minus 3 over 4n plus 8. And now let's write some partial sums. This is the sum of the first 5 terms, which is 0.9928. Sum of the first 10 terms is 1.273484. Sum of the first 100 terms is 1.5326. Sum of the first 1,000 terms is 1.5595. Sum of the first 5,000 terms is 1.5619. Sum of the first 10,000 terms is 1.5622. And sum of the first 100,000 terms is 1.56247. And now let's write the sum of the first k terms. So here's our expression: 3 over 4n minus 8 minus 3 over 4n plus 8. And I want to generate sum of the first k terms. So here's the first 15 terms. This term here is the kth term. So in the place of n, we have k. And then this is the term before the kth term. So in the place of n, we have k minus 1, and then simplify. For this term, we replace n with k minus 2. For this term, we replace n with k minus 3, k minus 4, k minus 5, k minus 6, k minus 7, and so on. And so this is our sum of the first k terms. And then we can see that the 320 here, 3 over 20 and 3 over 20, they get cancelled out. And they will drop out. And then the minus 324 and the 324. And then the 3 over 28 and 3 over 28. And then 3 over 32. And then the 3 over 36. And then 3 over 40. And then 3 over 44. And so we can see that eventually all of these terms here will get cancelled out. Will get cancelled. And so they just drop out. And then down here, what we can see is so first let's go ahead and cancel this part here. 3 over 4k minus 16. 3 over 4k minus 16. And then 3 over 4k minus 20. 3 over 4k minus 20. And then 3 over 4k minus 24. And 3 over 4k minus 28. And then 3 over 4k minus 32. And then 3 over 4k minus 36. And then this 3 over 4k minus 12. And then this one will also drop out. So we can see that eventually all of these will drop out. And so what's left will be the 3/4, 3/8, 3/12, 3/16, 3/16. And then for down here, it'd be the minus 3 over k minus 4, minus 3 over k, minus 3 over k plus 4. And what's left down here, and then also, we could also, these two will also drop out. So what's left is going to be the minus 3 over 4k minus 4, minus 3 over 4k, minus 3 over 4k plus 4, and minus 3 over 4k plus 8. So this will be the sum of the first k terms So the original series is the same as the limit of s of k as k approaches infinity. So notice that this is the sum of the first k terms. If we allow k to run to infinity, then we get the entire infinite series. And so s of k is this. And then as k approaches infinity, this term approaches 0, 0, 0, 0. So what we have left is these terms, these expressions right here. And so if we add all of these up, we get 25 over 16, which is 1.5625. And so we have the series with the expression 3 over n squared minus 4 converges to 25 over 16. And that's the end of the video.